Okay, so what I want to do today is we need to have a review of what we call summation notation, because I'm not sure in your background how familiar you are with this notation. The symbol for summation notation is this. This symbol is capital sigma, and it means to add in math. And that sigma typically tells us to do things like this. So I want to understand what that symbol says. Okay, so if you have data, and I'm going to do an example here. If you have data and you have, let's say you are finding out the number of hours your classmates slept. Okay, so number of hours of sleep. Okay, and you have then your subject number. This would be like just the count column in an Excel spreadsheet. So the subject number is always what is the I, the indexer. Okay, so we have subject number 1, subject number 2, subject number 3, subject number 4, and subject number 5. So we have the subject number. Okay, then we have what we call the value symbol. So the symbol that represents that subject's number. So this is, in general, that's going to be xi. So this is x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. Okay, and then this is actually where we have the data value. So that data value, if the first subject maybe slept 3 hours a night, the second subject slept 12 hours a night, the third subject slept 8, the fourth slept 16, whoa, lots of sleep there, and the last subject slept 5 hours. Okay, so this is how we would set up our sort of idea of how we look at data. And then what's real important to notice is that in that chart, if we wanted to graph that in some way, this is the x-axis. Therefore, it always counts what observation number you're at. So just like normal, it would count. There's observation number 1, observation number 2, observation number 3, observation number 4, or oops, I forgot 4. Let me go to my eraser. Okay, go back to my pen and go to 4 and then go to 5. Okay, so this 1 is really representing x sub 1, and this is x sub 2, and so forth, where these are the actual data values. Okay, so x1 has a data value of 3, x2, 5, 6, 7, 8, 9, 10, 11, 12, has one of 12. Subject 3, this is 3, and this is 12. Then this 4, 5, 6, 7, 8. This is 8. That's the third one. And the fourth is a 16, which is way up here. Just keep extending my axis. And then the fifth one is 5. And again, that would be what we call a dot plot of the data from previous. Okay, so now that we kind of understand how the indexes work, if I wanted to take that and do the sum from I equal 1 to n of xi, I don't want you to be nervous. It looks really scary, but all it does is say you start at number 1 and you go to the total. Okay, so this says I take x1 plus x2 plus x3 plus x4 plus x5. So I go in numerical order and just count up on the indices, and therefore this is just telling me in a quicker way to add my data points. So I do 3 plus 12 plus 8 plus 16 plus 5. And you can see that that total, if you add all those up, is 44. So this notation of the summation is just a way to say add them all up. Sometimes in statistics we don't put the n because we always add up all the data points. This will also equal, because of that, this will equal, if we just do the sum of xi, that means add them all up. So you'll see this notation right here that's being underlined a lot in the textbook and in my notes. You'll also see it as sometimes just the sum of x. So that's connected there. It should be connected. That x just says add them all up. We don't care what n is because we want to add them all up. So now that we know that, there are some order of operations within a summation, and so I want to do a couple. If I asked you to take the sum of 3x, what that would mean is, and we still have the same data points. Actually, let me erase that and give you a new example. Okay, so we're going to have the example of my data points are 3, 6, 5, 2, and 10. Okay, so if I want to sum x, right, what do? I add them all up. 3 plus 6 plus 5 plus 2 plus 10, and that happens to be 9 plus 5 is 14 plus 2 is 16. How about 26? Okay, so if the sum there is 26, if I want the sum of 3x, what that means is you take every data point and multiply it by 3. So you do 3 times 3 plus 3 times 6 plus 3 times 5 plus 3 times 2 plus 3 times 10. So you multiply each data point by 3 before. And why do you do it before? Because of PEMDAS. It tells you must do the multiplication before you do the addition, and that is no different here. And that total happens to be 78. I want you to also notice that if I say this, 3 times the sum of x, that means 3 times 3 plus 6 plus 5 plus 2 plus 10, and that is 3 times 26, which is 78. So I just, in a way, in an example, proved a property of the summation notation, is that multiplication can distribute in and out of the summation. If I wanted to do the sum of x plus 3, that would tell me I basically take the sum of x, which happened to be 26 from above, and add 3 to it, which is 29. Where if I had this sum of x plus 3, that tells me I got to do the parentheses first and add 3 to every data point before I add them. So I have 3 plus 3 plus 6 plus 3 plus 5 plus 3 plus 2 plus 3 plus 10 plus 3. And if you add all those up, that sum is 41. So you can see that the parentheses, when you have an addition sign, really matter because this answer and this answer were not the same. So you want to really be careful about that. What if I gave you something like the sum of x squared? Okay, well then you would square them all before you add them. So you'd take 9 plus 36 plus 25 plus 4 plus 100, and you would get 174. So I just wanted to go over some properties of those because it can be confusing when you're first learning those. We use these summation notation several times when we want to find the descriptive statistics of data sets.